Hi, my name's Keegan Hunt, and today, with the help of my partner Jocelyn, we'll be showing you how to make an adaptive brightness sensor using a Wheatstone bridge circuit. As you can see from the Falstad simulation, we have built it with a 10-volt source supply, two 1000 ohm resistors, a single 470 ohm resistor, and due to how Falstad has the programming, we're using a normal resistor as a photoresistor because the actual photoresistor doesn't go below 999. But we can still manually change the resistance, so it should all work good. So the adaptive brightness sensor works by turning the light on when it's bright. And depending on the level of brightness, the light will be dimmer or brighter. But when it is dark, the light will be off. And in its ambient light, it will also still be off, aka when the bridge is balanced. So, as you can see, when we run it, it works. And it does this because electricity, it wants to go through the path of least resistance. And while it still goes a little bit through this resistor, it takes a different path going through the LED and through this resistor here, which has a lower resistance on this side, and therefore making the electricity split off and going through and then going to ground this way instead. Depending on the level, of course, of brightness, the light will be brighter or dimmer. As you can see, it's now dimmed. And when its resistance is at 200, at 300, you can just barely see a hint of it. Of course, if we go above that, we will no longer be able to see it. Now, for a couple of calculations, the bridge balance. To have the bridge balanced, you need resistance 1 over resistance 2 to be equal with resistance 3 over resistance 4. Of course, the easiest way to have this happening is just using the same amount of resistors on both sides. Of course, that doesn't always happen, but let's say the photoresistor is at the exact same as this side, so 470. That's 1000 over 470 equals 1000 over 470. And when the bridge is balanced, these 2 points equal the same voltage. In the bottom right, you can see 3.197 volts at both points. And no current will run through whatever you have connecting in the middle. In this case, an LED. As you can see in the bottom right, there is no current. There is no current going through it. Of course, there's other ways to have a bridge balance because there wouldn't be a reason to need it if this was the only way. You could have resistances that are higher or lower, but are of the same fraction. Let's say 1470. If you simplified it, then that would also work to balance the bridge. Another calculation, we'll put this back at 1000 for this calculation. Voltage drop. So Falstad actually shows you the voltage drop, but we'll be using the calculations, which you'll need the total current by taking the total voltage, which would be your source voltage, and then dividing that by the total resistance, which you can just take from each side at a time. So since they're in series, there's 1000 plus 1000, 2000. So 10 divided by 2000, that will be 0.005. And you take 0.005 and you times it by the resistance. So in this case, 1000. And when you do this, you get 5 volts. since they're both 1,000, the total voltage drop is 10 volts, which equals source, which means that's correct. And Velstad can also help you confirm such. The bottom right, you can see the VD voltage drop is 5 volts. And over here, we can see that the voltage drop is 6.8 and 3.197. Of course, we're going to round it up when we do our calculations. So 1,470, 10 divided by that, is roughly 0.07. So then you times that by 1,000, which gives 7. Not exactly what Falstad says, but we round it up, so it's going to be a bit different. And then 470, so 0.007 times that is roughly 3. Of course, Falstad shows the true number, but with the rounding up, this is what we get. And that does equal the source voltage. My partner Jocelyn will be showing you how to put it all together on the breadboard so you can see and interact with it.
To build this breadboard, you're going to start off by putting 2 wires, one in the positive, one in the negative, and then you're going to get an LED, and you're going to place it on your board like this in the middle. You're going to take a wire, hook it up to the positive, like that, and then take an orange wire and put it in the middle. Like that. Take this resistor and set it next to the yellow one, going straight down. Like that. There you go. Then you're going to take your 470. Oh, that's a 1K resistor, by the way. And you're going to take the 470, or the 560, sorry, 560, and set it in the middle, like this. Set it in the middle of them. And hook this yellow wire, right here, in the negative. I switched the 1K resistor in the middle of the LED and the 560 resistor, just letting you know. Alright. And then we're going to take another 1K resistor and place it next to this orange wire that is in the middle. And then place it next to the LED. And then we're going to take the sensor and place it right next to the 1K resistor. And then in the same line as the wire in the 560 resistor, like that. And then you're going to take the yellow wire and make sure it's placed in the negative right there. Move this next to it, just like that. Alright, and then you're going to take this orange wire and you are going to put it in the negative.